All right, rocks and weathering. Does this scene look like a desert? It is, but not on Earth. These rocks are found on Mars. Blowing sand wears away some rocks on the surface. Fog containing acid dissolves and breaks down other rocks. Over time, the rock breaks down into small particles, covering the planet with reddish sand. What are two processes that break down rocks on Mars? Give an example of rocks you have seen that were changed by natural processes. All right, what breaks down rocks? Even the hardest rocks wear down over time, on Earth or on Mars. Natural processes break down rocks and carry the pieces away. How do scientists know what processes shaped Earth in the past? Geologists make inferences based on the principle of uniformitarianism. This principle states that the geologic processes that operate today also operated in the past. Scientists can infer that ancient landforms and features formed through the same processes they observe today. Erosion. Erosion is the process of wearing down and carrying away rocks. Erosion includes the breaking of rocks into smaller pieces. It also involves the removal of rock particles by wind, water, ice, or gravity. Weathering. Weathering is the process that breaks down rock and other substances. Heat, cold, water, ice, and gases all contribute to weathering. The forces that wear down mountains, like those in Figure 1, also cause bicycles to rust, paint to peel, and sidewalks to crack. Erosion works continuously to weather and carry away rocks at Earth's surface. The Sierra Nevada are much younger than the Appalachians. Predict how might the Sierras change in the future and explain your answer. What causes weathering? If you hit a rock with a hammer, the rock may break into pieces. Some forces of weathering break rock into pieces, as a hammer does. The type of weathering in which rock is physically broken into smaller pieces is called mechanical weathering. A second type of weathering, called chemical weathering, also breaks down rock. Chemical weathering is the process that breaks down rock through chemical changes. Mechanical weathering. If you have seen rocks that are cracked or split in layers, then you have seen rocks that have undergone mechanical weathering. Mechanical weathering usually works slowly, but over very long periods of time, it does more than wear down rocks. Mechanical weathering, as part of erosion, eventually wears away whole mountains. All right, you're going to match each description to an example shown in the photos on the next page. How might more than one agent of mechanical weathering operate in the same place? So you're going to use these and match them to these pictures. Agents of mechanical weathering. The natural agents of mechanical weathering include freezing and thawing, release of pressure, plant growth, actions of animals, and abrasion. Abrasion refers to the wearing away of rock by rock particles carried by water, ice, wind, or gravity. Human activities such as mining and farming can also cause weathering. In cool climates, the most important agent of mechanical weathering is the freezing and thawing of water. Water seeps into cracks in rocks and freezes there, expanding as it freezes. The ice then forces the rocks apart. Wedges of ice in rocks widen and deepen cracks. This process is called frost wedging. When the ice melts, water seeps deeper into the cracks. With repeated freezing and thawing, the cracks slowly expand until pieces of rock break off. All right, chemical weathering. Chemical weathering can produce new minerals as it breaks down rock. For example, granite is made up of several minerals, including feldspar. As a result of chemical weathering, the feldspar minerals eventually change to clay. Chemical and mechanical weathering often work together. Chemical weathering creates holes or soft spots in rock, so the rock breaks apart more easily. As rocks break into pieces, more surface area is exposed to chemical weathering, as shown in Figure 3. The agents of chemical weathering include water, oxygen, carbon dioxide, living organisms, and acid rain. So water. Water weathers some rock by dissolving it. Water also carries other substances that dissolve or break down rock, including oxygen, carbon dioxide, and other chemicals. All right, weathering and surface area. Weathering breaks rock into smaller pieces. While the pieces are usually irregularly shaped, you can model the process with the cubes. The diagram shows what would happen if a rock cube broke into smaller cubes. By how much does the surface area increase? How would the rate of weathering change? All right, oxygen. The oxygen gas in air is an important cause of chemical weathering. Iron combines with oxygen in the presence of water in a process called oxidation. The product of iron oxidation is rust. Rust makes rock soft and crumbly and gives it a red or brown color. Carbon dioxide. Another gas found in air, carbon dioxide, also causes chemical weathering when it dissolves in water. The result is a weak acid called carbonic acid. Carbonic acid easily weathers some kinds of rock, such as marble and limestone. All right, living organisms. As a plant's roots grow, they produce weak acids that slowly dissolve rock around the roots. Lichens, plant-like organisms that grow on rocks, also produce weak acids. Acid rain. Rainwater is naturally slightly acidic. Burning coal, oil, and gas for energy can pollute the air with sulfur, carbon, and nitrogen compounds. These compounds react with water vapor in clouds, making acids that are stronger than normal rainwater. These acids mix with raindrops and fall as acid rain. Acid rain causes very rapid chemical weathering of rock. All right. Acid rain chemically weathered the statue of the lion. Which agent of chemical weathering most likely formed this limestone cavern? Okay, assess your understanding. Define. Mechanical or chemical weathering physically breaks rock into smaller pieces. Circle the examples of chemical weathering. Underline the examples of mechanical weathering. Freezing and thawing, oxidation, water dissolving chemicals, abrasion, acid rain. Many ancient monuments are made of marble. Some are located in highly polluted cities. How might the pollution affect the monuments? How fast does weathering occur? Visitors to New England's historic cemeteries may notice a surprising fact. Slate tombstones carved in the 1700s are less weathered and easier to read than marble gravestones from the 1800s. Why is this so? Some kinds of rocks weather more rapidly than others. The most important factors that determine the rate at which weathering occurs are the type of rock and the climate. All right, so type of rock. The minerals that make up the rock determine how fast it weathers. Rocks that are made of minerals that do not dissolve easily will weather slowly. Rocks weather faster if they are made of minerals that do dissolve easily. Some rocks weather more easily because they are permeable. Permeable means that a material is full of tiny connected air spaces that allow water to seep through it. The spaces increase the surface area of the rock. As water seeps through the spaces in the rock, it carries chemicals that dissolve the rock. The water also removes material broken down by weathering. All right, which weathered faster? The data table shows how much stone was lost due to weathering for two identical pieces of limestone from different locations. So use the data to make a double line graph. Be sure to label the axes and provide a key and a title. All right, stone A or stone B weathered at a faster rate. So you need to circle that. What can you infer caused the difference in the rates of weathering? All right, climate. Climate refers to the average weather conditions in an area. Both chemical and mechanical weathering occur faster in wet climates. Rainfall provides the water needed for chemical changes as well as for freezing and thawing. Chemical reactions occur faster at higher temperatures. That is why chemical weathering occurs more quickly where the climate is both hot and wet. Human activities such as those that produce acid rain also increase the rate of weathering. All right, tombstones 1 and 2 are both around 200 years old and are in the same cemetery. Stone 1 or stone 2 has weathered more. What might explain that difference? And how do you know that the type of rock is the only difference between the tombstones? All right, and for assess your understanding, why does permeable rock weather more quickly than less permeable rock? And why are tombstones in a cemetery useful for comparing rates of weathering?